Hey everyone, welcome to today's Explainer. If you're a focused learner who's absolutely fascinated by what it actually takes to keep those massive, multi-ton vessels moving across the ocean, well, you are definitely in the right place. Today, we're putting you right in the steel-toed boots of a first-year marine engineering student. We're going to map out the exact academic gauntlet that transforms you from a fresh high school graduate into a hardened professional, ready to command a ship's engine room. So let's just dive right in by posing our central question for today. What does it actually take to master the heart of a massive ship? To answer this, we're going to completely reverse engineer your path. We'll start by looking at the ultimate professional standards you need to hit, and then we'll trace it all the way back to see exactly how your first-year curriculum builds the blueprint to get you there. And to make this super practical and real, we are grounding today's explainer entirely in the rigorously structured 2025 Bachelor of Engineering in Marine Engineering curriculum from Anna University. It's honestly the perfect roadmap of what you should expect from a modern, world-class program. The gears, the factory floor, the textbooks, it all points to making serious progress through incredibly structured knowledge. Okay, so here's our agenda. First, the ultimate destination. Second, Semester 1, the boot camp. Third, Makerspace hands-on day 1. Fourth, Mechanics and Thermodynamics. And finally, charting your career path. Let's get into it. Section 1. The ultimate destination. Defining the professional marine engineer. Now, this specific outcome you're looking at, this is the North Star of your entire academic journey. Every single math equation you balance, every line of code you write, and every piece of metal you weld over the next 4 years is meticulously designed to build your proficiency in operating and maintaining massive marine propulsion systems. You aren't just learning to pass tests. Well, actually, scratch that. You are passing tests, but the real end goal is learning how to keep a ship alive at sea. But, it's really not just about turning wrenches. Beyond the physical hardware, your long-term career success relies heavily on your diagnostic expertise. You absolutely must equip yourself with advanced simulation software and modern engineering tools to troubleshoot highly complex systems. And you have to do all of this with a strict commitment to ethical practices and teamwork. That is the true profile of a professional marine engineer. Section 2, Semester 1, the boot camp, laying the academic groundwork. All right, I need you to brace yourself for this number, 39. Yeah, that is the staggering number of contact periods you will have per week in your first semester alone. Combine that with 27 academic credits, and it is a massive, incredibly demanding workload. It's going to require serious time management literally from day one. It's an academic gauntlet, but it's absolutely necessary to prepare you for the intense pressures of the marine industry. Now, that heavy first semester schedule is actually a carefully balanced mix designed to build you into a well-rounded engineer. Sure, you have basic sciences like calculus and physics and engineering sciences like Python, but do not overlook the humanities. Courses like English Essentials and the Heritage of Tamils. You're being trained to communicate effectively and understand cultural context, which is a total game changer when you're working with super diverse crews out on international waters. And you might be wondering, why programming? A seemingly standard course like Python isn't just about learning to code for the sake of it. In marine engineering, Python is the absolute foundation for the advanced diagnostic and simulation software you'll be relying on at sea. It teaches you problem-solving and data analysis, skills that will translate directly to monitoring engine performance and automating vital ship systems later on. Section 3, Makerspace, hands-on day 1, practical maintenance skills. You are going to get your hands dirty from the very beginning. Step 1 involves physically taking apart and reassembling everyday home appliances, think washing machines and air conditioners, just to intuitively understand mechanisms. Then, Step 2 throws you right into arc and gas metal welding on steel plates. Step 3 has you wiring actual electrical distribution boxes, and Step 4 pushes you into modern tech with 3D printing and laser cutting. You're learning physical maintenance immediately, no waiting around. And the true challenge, and honestly the true brilliance of your first year, is bridging these two completely different worlds. On one hand, you are grappling with intense, abstract math. Multiple integrals, partial derivatives, and complex equations in applied calculus. But on the exact same day, you're dealing with the gritty, physical reality of welding joints and wiring electrical circuits. As a marine engineer, you have to be perfectly comfortable existing in both of these spaces. Section 4, Mechanics and Thermodynamics, the Engineering Blueprints. First up in Semester 2 is Engineering Mechanics. And listen, this isn't just another academic hurdle to jump over. Understanding statics, rigid bodies, moments of inertia, and friction, that is the literal blueprint for your career. This is the science of ensuring the structural integrity of your machinery as your ship physically battles the ocean. It's literally the physics of survival. Then, by semester 3, applied thermodynamics becomes the fundamental language you must speak. It's all about energy transfer, how you understand and operate massive marine internal combustion engines, complex refrigeration units, and high-pressure boiler systems. If engineering mechanics is the skeleton of the ship, thermodynamics is, without a doubt, its beating heart. Section 5. Charting your career path, connecting curriculum to the ocean. Taking a macro view here, your journey is just incredibly structured. You evolve directly from those bootcamp foundations of math and basic makerspace tools in semester 1, straight into highly specialized courses like marine engines by semester 3. By semester 6, you are actually entering the afloat training laboratory, applying everything to real marine environments. And finally, by semester 8, you're entirely focused on internships, completely ready to step into a professional role. And by mastering those grueling basics early on, you unlock the really advanced specialized modules. We're talking seamanship and survival at sea, fire prevention, marine auxiliary machines, alongside strict international maritime organization requirements. The entire curriculum strictly aligns with global maritime regulations, ensuring that when you graduate, you are an internationally qualified maritime professional. So we've reverse engineered the path. From the overarching goal of mastering propulsion systems, back through the demanding 167 total credits of your degree, right down to your very first 39-hour week of calculus and welding. Knowing the intense, blueprint-level preparation required to survive out there, the only question left for you as a prospective first-year student is this: do you have the grit to step into the engine room and engineer the future of the seas?